Algebra. We're going to cover 9.3. It's a short and simple section. It's kind of an introduction, not kinda. This is an introduction to the idea of supply and demand. So that refers to basically, how companies price their product greatly depends upon the demand. So something to remember. You're going to see the word widget a lot, and that is just any unnamed product. So it's just kind of a hypothetical, if this company makes this widget, so forth. But something to remember, as the price of a product increases, the demand for it decreases. So same with, and it affects supply, but as the price decreases, the demand increases. So when something's really inexpensive, right, a ton of people are going to want to buy it. When something is super, super expensive, then not as many people are going to be able to buy it. So the price and demand go hand in hand. And you probably already know this, grocery stores, retailers, they buy a product at wholesale, then they mark the price up in order to make a profit. So we're going to do some examples. Number one, Wayne's Widget World sells widgets to stores for $9.20 each. A local store marks them up $8.79. What is the retail price? So our retail price equals the wholesale plus the markup. So in this case, the wholesale was $9.20 plus the markup of $8.79. So our retail price would give us a total of $17.99. So that is our retail price. Okay, so that's how much they would actually sell it for so they could make a profit. The Noki Corporation sells hockey sticks at a wholesale of $103. So $103 is our wholesale price. If a store marks this up 106%, what is the retail price? So remember, it's our wholesale plus our markup. So it'd be 103 times 1.06 because 106% would be 1.06 as a decimal. So it's the wholesale plus the markup. That would equal our retail price. So I'm going to go ahead and enter this 103 plus 103 times 1.06, and I get a retail price of $212.18. Okay. All right, so here is a basic supply and demand curve. This point here in the middle is referred to as the equilibrium. And that's where the two meet or intersect. And so if you'll notice down here, here's the price. This is price. This here is quantity. So how many are being produced? So as the price increases, notice the demand is decreasing. As the price gets lower, my demand is much higher. And then we also have this supply. That's how many units are being produced. So explain what happens if the sale price is set at $9. So if I'm way over here, my supply will surpass the demand. So if you look up here, supply is way up. There's lots of units being produced, but the demand for it is much smaller because it's so expensive. So the company is going to have a lot of product and not be able to sell it. Use the graph above to explain what will happen if the price is set at $2.75. So if I'm way over here, all of a sudden I have that my, my demand is going to surpass the supply. Look at here's my demand, but I'm only producing so many. So you don't have as many units, but everybody wants them. And they're probably not being produced at much because they're being sold so cheaply. Number 4, an automobile DVD navigation system has a wholesale price of $4.97. A national chain store sells them for $879.99. What is the markup? So first I need to find the difference. So here is the sale price minus the wholesale price. And that gives me a markup of $382.99. So that is the markup in dollars. If I wanted to find it as a percent, you would do the markup divided by the wholesale. So $382.99 divided by the wholesale price of $4.97, and I got 0.77, or it was a 77% markup. So there is both the dollar price and the percent at which it was marked up. Number 5, an automobile ski rack is sold to stores at a wholesale price of $38. So here's your wholesale price. The store has a $23 markup. So $38 plus my markup equals a retail price of $61. Remember, wholesale plus markup. Find the percent of the markup to the nearest percent. So remember, you do markup divided by wholesale, and that gives me 0.605 or 0.5% markup. All right, for number 6, the one in the homework, they give you the function. I am going to, in part A, I'm going to give us that expression. So the function is y equals negative 155.9x plus 7,428.85. And so I've already entered this data and I came up with the equation. So this is our equation. And they'd like us to find, use the demand function to determine how many widgets to the nearest 100 retailers would buy at a price of $20. So here's our X, here's Y, so this is our wholesale price. Notice the cheaper it is, the more it is purchased. The more expensive the item gets, the less people purchase it. So I'm going to go ahead and enter the price of $20 into this equation, and I get 4,310.85, but I can't have 0.85 of a unit. So at that cheap of a price, at $20, they will purchase, let's round this to the nearest unit, 4,311 units. All right, part B, how many widgets at a price of $45? So how many would people purchase if the price increased all the way? So it's obviously going to be less than 1,400. So I'm going to plug it into this equation again. So negative 155.9 times $45 plus 7,428.85. And I get that y equals 413. So only 413 units, look how much it dropped, would be sold if they increased their price all the way to $45. Last one, very similar to one that you have on your homework. So what is the equilibrium price? Remember, our equilibrium is right here in the middle. So our equilibrium price is $40. What will happen if the price is set at $35? Well, the demand will surpass supply, because supply is way down here. How many aquapods are demanded at 35? Right here, wait, how many? So how many pods are demanded at a price of 35? The demand is right here at the letter Y. How many aquapods are supplied at a price of 40? So I'm looking at supply right here, which would be X. What will happen if the price is set at 45? So at 45, supply will surpass demand. And that's very similar to how you'd answer the one on your homework. And that completes that section.